Hello and welcome to BYJU'S IAS. Welcome to another episode in the series of Explain. The topic of this week is space hurricane. Now when you hear about this term space hurricane, it appears to be taken directly from a sci-fi movie. But then what does this term exactly signify? After all, hurricane is something that we come across in our everyday parlance whenever we are talking about climatology. And whenever we talk about hurricanes, we basically end up representing those areas where due to acute low pressure, there is a circulatory motion induced in the winds. So why is it that a phenomena is referred to as a space hurricane? What are the causative factors behind it? Along with that, in this video, we shall be addressing few of the basic concepts which lead to such phenomena being experienced over certain parts of the globe. And we shall also be analyzing why is it that only in certain parts of the planet do we end up experiencing such kind of atmospheric conditions. So let us first of all start with the basic. That is, what do we mean when we talk about a space hurricane? What exactly is a space hurricane? So if you look at the figure in front of you, you will be able to analyze that charged particles, or in a way light in a pattern of circulatory motion, is present over the surface of the earth in the upper atmosphere. And this presence of light in a circulatory pattern is why the name hurricane has been provided. But more importantly, this is something which has been experienced to be occurring at a height of close to around 100 to around 800 kilometers away from the Earth's surface. And hence, the name space has also been attributed to it. So this kind of lighted pattern that you are able to see, these lights are something which is very common along the northern and the southern polar regions of the Earth. But then, this occurrence of space hurricane is special because here we get to see a circumambulatory path followed by these lights. And this observation was basically carried out in a great detail. And this particular pattern had a distinct center or an eye. Along with that, it had strong winds of plasma. In the case of normal hurricanes which end up occurring on the Earth's surface, we experience movement of air particles. But in the case of space hurricanes, there is a very strong movement of plasma or electrically charged gas particles. And that is why such kind of colored pattern is something which is experienced. But more importantly, the presence of a distinct eye along with an anti-clockwise motion which was observed in the northern hemisphere, that is what led to the naming of this phenomena as a space hurricane. Now when we talk about the exact extent of this phenomena, this was found to be extending for close to around 1,000 kilometers or roughly around 620 miles across in the form of diameter. And from the top of the Earth's surface, it was experienced at a height of more than around 100 kilometers, extending up till a height and an upper ceiling of around 900 kilometers. So this kind of phenomena, how was it formed? What was the reason that we ended up experiencing this? So if we look at the exact formation of these space hurricanes, the formation is pretty simple. Just like we end up observing auroras or the northern and the southern lights across the polar regions of the planet, similarly, we also had the charged particles being formed in the polar regions, but the only difference was that in this case, the lighted particles or the plasma was found to be in a circulatory motion. And in this figure, I hope you are able to see the lightly colored orange particles. This is clearly an artistic imagination and representation of what a space hurricane would have looked like. Now, these tiny dots or particles, they end up representing electrons, which are falling continuously over the magnetic poles of the Earth. Now, it all might seem very complicated. That why is it that electrons will fall only in some parts of the globe? Why is it that it is experienced only in the polar regions? And along with that, why is it that after all a light is emitted? If electrons travel from one place to another, they do not end up emitting light. So why is it that in this particular case, a lighted pattern was observed? So all this is basically addressed if we understand the basic concept behind it. The concept behind formation of these lighted phenomena, these lighted exhibitions, all of that is based upon one key factor, and that is the Earth acting as a magnet. The planet that we live on, it acts just like a bar magnet. And just like a bar magnet has its own field, similarly, Earth also has its own magnetic field. Now, when solar rays, along with the solar rays, you have plasma and electrons and other particles which are released from the surface of the sun. When they interact with the magnetic field which is actually expressed by the Earth in itself, that is what leads to such kind of atmospheric phenomena being observed, and especially along the northern and the southern poles. So overall, we see that there are two determining factors in the formation. One is the Earth acting as a magnet, and second is something that we have talked very briefly about. That is the sun acting as a source of charged particles. So let us understand each one of them individually, and thereafter let us paint a comprehensive picture and thereby understand the presence of this phenomena. So when we talk about Earth as a magnet, what is it that we mean by it? So as we all are aware that Earth has got various different layers in the interior of it. Now, the Earth's surface broadly along with its interior can be classified to have a crust, a mantle, an outer core which is in liquid state, along with an inner core which is generally found to be in a solid state. Now this outer core, and it is very important to understand that this is in a liquid state. This outer core is basically present and has a predominant presence of iron and nickel. So this presence of iron and nickel is something which has been present since the formation of Earth in itself. It is not a new phenomenon. At the point close to around 4 to 5 billion years ago from present, when Earth was in its initial stages of formation, at that point itself, the heavier minerals, that is iron and nickel, they settle down in the region of the core. Now, Earth as a planet keeps on rotating around its axis continuously day in and day out. That means all the layers present in the interior along with the Earth's surface, they also follow this rotatory motion. But then this outer core, which is in liquid state, when this continues a rotatory motion, there is a magnetic field which is induced because of the presence of these minerals, that is iron and nickel. So in a way, putting it in a simplistic manner, we can basically surmise that, see, as the outer core keeps on rotating around the axis, outer core being in liquid state, that means movement of liquid ions in a circulatory motion. And that is enough to induce a magnetic field. So as we saw, just like in the case of a bar magnet, the Earth also exhibits its own magnetic field. And this is something which was first of all verified in 1785 itself by Coulomb. And it was at that point of time when it was understood that Earth will have a magnetic field of lines all around itself. Now, this magnetic field, that helps us quite significantly. Why is it so? So to understand it in a very basic manner again, when you have charged particles or electrons being thrown out from the sun's surface or from the outer part of atmosphere of the sun, these charged particles are very ably deflected by the magnetic field which is present around the Earth. Had this magnetic field not been present, then these charged particles would have then interacted with our atmosphere and would have taken away all the gases which we find in our atmosphere as of now. So in a way, the presence of these magnetic fields, they help conserve the atmosphere in its present form. In fact, when the Earth was being formed, close to around again 4 to 4.5 billion years ago from present, at that point of time, the Earth did not have such a distinct atmosphere. And you will be very interested to know that at that point of time, our atmosphere was primarily dominated by hydrogen and helium. So, at that point of time, because we did not even have a very strong magnetic field, charged particles from the sun continued to bombard the Earth's atmosphere and took away all the gases that we saw at that point of time, that is hydrogen and helium. So that is why when you come across various different planets which do not have a strong magnetic field, you will find there's a distinct lack of atmospheric gases. And the reason being very, very simple. The charged particles flying away from the sun at a speed of thousands of miles per hour, they blow all the gases away and you are left with a bare surface. That is the reason why we do not see any distinct atmospheric layer over the planet Mars. Now, once we have understood why is it that Earth acts as a magnet, then we go on to understand the other factor in the whole formation of these atmospheric phenomena. That is the star of our solar system, or the sun. Now, when we look at the sun with our bare naked eyes, it appears to be calm and without much of an activity. But a closer analysis paints a very different picture. Upon closely analyzing the sun's surface, we are able to see the various kinds of disturbances which are emitted from the sun's surface. The sun in itself is so large and is such a great source of heat. To just give you an idea, it takes close to around 170,000 to 180,000 years for heat to travel from the inner part of the sun, that is the core, to the outer part of the sun. And keep this in mind, that it takes close to around 170,000 to around 180,000 years for heat to travel from the inner part to the outer part. Now, why is that? After all, heat from the sun reaches us on the planet Earth, which is around 93 million miles away, in a matter of few seconds. So why is it that heat takes so much amount of time to travel within the interior structure of the sun itself? The answer is very clear. That is because of the magnetic field. Just like the Earth, the sun also ends up having its own distinct magnetic property. And because the size of sun in itself is so large, it is easy for us to imagine what should be the size of the magnetic field that is actually exerted by the sun. It will also be very, very strong. So because of this magnetic field exerted from the interior of the sun, the heat takes some bit of time. Matter is not allowed to travel so freely from the interior of the sun to the outer part of the sun. Now, sometimes what happens is that this magnetic field either becomes very strong in certain parts of the sun or it becomes very weak. Now, when magnetic field will become very strong on a part of the sun, let us assume in this portion of the sun, what is it that we shall experience? Heat will no longer be able to travel to the surface. So these will become cooler. Now, since these are very, very highly charged in terms of their magnetic influence, they try to escape from the surface. And many of the times, there are various eruptions and explosions experienced on the sun's surface as well. So that is where we come across various properties such as solar flares and coronal mass ejection. Now, what is a solar flare? Now, we saw that how in certain parts the magnetic field becomes very, very strong and those regions become cooler. Such cooler regions on the surface of the sun are what are referred to as sunspots. So, solar flares are basically intense bursts of radiation which appear to be coming out of the surface, as you can see in the animation on your screen. So these intense bursts, they release huge amount of charged particles from the surface of the sun. And all these charged particles, they end up following the magnetic field lines which are exerted by the sun in itself. Now, this solar flare is one of the most explosive events that you will come across happening around the solar system. But whenever this solar flare is observed, around 8 to 12 hours after that and extending up to a few days, a significant amount of matter is also released from the surface of the sun. And that is what is referred to as coronal mass ejection or CME. Now, what is coronal mass ejection? The name or the term in itself tells us what it means. Means something or some mass is being ejected from the corona or the outer part of the sun. So, due to the disturbance that has happened in the magnetic field due to the presence of sunspots and occurrence of solar flares, what we experience is a significant proportion of mass from corona is also something which is expunged from the surface. And this mass, just to give you an idea about the size of it, to give you an idea about how humongous it is, if you will analyze, then this mass of corona which is released into the solar system, if you compare it, this is the size of the Earth. So that gives you an idea about the total amount of mass that gets released whenever there is an occurrence of a CME or a coronal mass ejection. Now, what happens as a result of that? So once these masses are released from the surface of the sun, they end up traveling throughout the solar system at a speed which is thousands of miles per hour. Sometimes it reaches the speeds of close to around 2000 miles per second. So they are able to cover almost the entire solar system. And it reaches Earth very, very quickly. And when this mass of plasma or charged particles, when they hit our Earth's surface, rather the magnetic surface of the Earth, then we end up observing various incidents happening. So as you can see from this representation, which has been provided by the European Space Agency, you get a clear-cut idea that how the geomagnetism, or basically the magnetic field exerted by the Earth, it ends up protecting the Earth's surface in itself from this harmful mass of plasma as well as solar eruptions which are emitted into the solar system. And you will be able to see that how all these materials, they travel outward from the surface. But then there is a kind of a protective layer. And that is why our atmosphere is protected, and that is why our atmosphere still has the gases which is required for life on Earth. Now, once we have understood what is the concept of Earth acting as a magnet, once we have looked at what is the concept of sun releasing significant amount of energy, significant amount of charged particles, then let us focus on the formation of these patterns. So first of all, if we look at the magnetic field around the Earth's surface, you will find that the density of the field lines is maximum around the polar region. Just like what we see in the case of any kind of bar magnet, that you have a bar magnet having a north and a south pole, they will have magnetic field lines acting all around them. But the maximum density of the field lines shall be towards the two poles of the magnet. Similarly, in the case of Earth as well, the maximum density of all the magnetic field lines is around the polar region or around the magnetic poles of the Earth. And I hope we are aware of the fact that our magnetic poles and our geological or geographical poles, they are distinct from each other. The magnetic north and the south pole of the Earth, it keeps on changing over a period of time. And it is purely determined and derived by the internal movement of the Earth. For example, just last year, it was actually observed that the magnetic north pole has shifted. Earlier, it was present around the region of Alaska, and it carried out a major shift towards a region of Siberia in Russia. So why is it that magnetic field lines keep on changing? The answer is again, once we analyze about the interior and once we get to understand that the outer part of the core is in a liquid state which is continuously rotating, we get a broader idea that when you have a liquid blob of mass which is rotating around its axis, chances are that this blob of mass might get accumulated in some region or the other. So depending upon how this blob of liquid moves in the interior of the Earth, the polarity along with the north and the south poles, they keep on changing in case of Earth's magnetic polarity. Now, we have seen that around the region of the poles, we have the maximum density of magnetic lines of action. So it is no coincidence that around this region where you find maximum number of magnetic field lines to be present, it is in these regions that the Earth's atmosphere gets lighted up now and again due to the presence and bombardment of matter coming out from the sun. This is what is also represented as a lighted oval or the oval of northern and the southern lights. Because when we talk about the northern and the southern lights, when we talk about auroras or this kind of lighted features and phenomena, they don't occur in sinuous and straight lines. Most of the times, they end up impacting the polar region in a semicircular or a completely circular or an oval shape. And that is why we end up observing these northern lights from a considerable distance in the lower latitudes as well. For example, sometimes when you go to 60 degree north, ideally it is far away from the poles. but still you will be able to visualize and you will be able to experience these northern and southern lights because they occur in an oval shape. Now, once we know about the region where it is formed, what is the reason why we end up observing light? So for that, I need you to look at and understand this particular animation in detail. Here, you observe that charged particles from the sun, they are hitting the upper layers of atmosphere. And I hope we are aware that if this is the Earth's surface, then up from the Earth's surface, from around 100 kilometers away from the Earth's surface, around 90 to 100 kilometers away from the Earth's surface, to a region of around 1000 to 2000 kilometers away from the Earth's surface, we still have the presence of gases. The density of these gases might be very, very less when compared to the density of the same gases on the surface. But still, you will find the presence of gases such as oxygen and nitrogen in these upper layers of atmosphere. Now, the presence of oxygen and nitrogen, that ends up providing large number of atoms and molecules in these portions, upper portions of the atmosphere. Granted that its density is very less, but when it is hit by charged electrons coming directly from the sun, these charged electrons, they have all the required characteristic and phenomena to cause a kind of disturbance. What do we mean by that? So when you have charged particles, charged electrons traveling across such a large distance, obviously it would have gained a significant amount of velocity in itself. Along with that velocity, there is also the presence of the charge. So when that charged particle bombards the oxygen and nitrogen molecules present high up in the Earth's atmosphere, the oxygen and nitrogen molecules also get excited. Electrons leave the outer orbit of these molecules. So now we have a state where in the upper atmosphere we have oxygen and nitrogen which are present in an excited state. How does that help us explain the formation of lights? Any ion does not give us a lighted format. But when these excited oxygen and nitrogen molecules, when they return to their normal state, they end up emitting beautiful patterns of light. And it is these lights that we end up experiencing in the form of auroras. And they occur along the northern polar region as well as the southern polar region. The reason again being the same, that in these areas the density of magnetic field lines is the maximum. Now when it occurs in the northern polar region, it is referred to as the northern light, or what is also referred to as aurora borealis. And when the same phenomena is observed in the region around southern polar area, then they are referred to as southern lights or aurora australis. So we have aurora borealis as well as aurora australis, which ends up occurring along the northern and the southern polar regions respectively. But then here again, one question should automatically come into your minds. It is okay to understand that when the charged molecules of oxygen and nitrogen, when they return back to their normal state, they end up emitting lights. But then, why is it that we get to experience such great patterns of light? Sometimes you observe a very large presence of the color green. Sometimes you observe the presence of the color purple or pink. And sometimes, very rarely, we also end up observing the color red. Now, all these colorations, are they randomly chosen, or is there a reason behind it? As is the case with most of the phenomena in terms of geography and astronomy, there is an exact science behind it. Now, depending upon which particular molecule is actually hit by these charged particles, we have different coloration of light which is visible to us. Let me elaborate a bit. Now, suppose here we have the Earth's surface. At a particular height away from the Earth's surface, let us suppose that we have presence of oxygen ions in majority. Now, when the charged particles or electrons will bombard the oxygen molecule, it will primarily and automatically lead to generation of a green light. But sometimes, when these charged particles hit the nitrogen molecule which is present, then in those cases we end up observing a pink or a purple tinge to these lights. Sometimes, very, very rarely, we end up observing red coloration as well. Red normally ends up indicating that the temperature is very high. So whenever you get to observe red color in the case of these auroras, means the interaction between the molecules and the charged electrons is happening at a great distance from the surface. That part of atmosphere is directly exposed to the solar energy. And there is not much which prevents those solar energy and those electrons to bombard the molecules. And this red color is again imparted by bombardment of oxygen molecules. But then the only difference being that when you have oxygen molecules being bombarded at a height maybe around 1,000 or 2,000 kilometers up from the Earth's surface, it is only in those circumstances that you will be able to see the red color. But if the bombardment is something which is experienced at a lower height, maybe roughly around 800, 900 kilometers from the surface, or maybe around 100, 200 kilometers from the surface, if the oxygen molecule is bombarded, we end up experiencing the green light. Now, this is a very basic concept, but it forms a very important part as far as the prelims examination is concerned, because we can expect questions to be asked from this portion directly. Now, once we have understood what we know by auroras, what is it that we call as aurora borealis and aurora australis, along with that, why is it that we see different coloration of light? Now let us understand that is it so that all solar activities will impact the Earth's surface or the Earth's atmosphere? Because in that case, the solar activities are simply very, very large in number. So we on Earth shall be experiencing these phenomena almost on a daily basis or almost on an hourly basis. But we do not end up experiencing that. So that means all the solar activities do not impact the Earth's surface. Only that portion of solar activities which face the Earth directly, something which is visible to us, only those portions and those phenomena end up impacting the Earth. Because if you look at it and if you try to understand it, if suppose this is the sun, then only those parts or only those solar phenomena which are emitted or which are experienced in the phase which is directly in front of the Earth, only those will end up impacting. Those portions and the part of the sun which is away from the Earth, which is facing in the direction opposite to the Earth, in those portions, we do not have any kind of northern and southern lights which impacts the Earth's surface. But sometimes, even if there is a solar flare, even if there is a coronal mass ejection which is experienced on the side which is facing the Earth, still it does not lead to formation or creation of such lighted pattern. Why is that? That is primarily because the condition of our Earth's atmosphere, along with the magnetic field lines of the sun and the Earth, that keeps on changing. Sometimes you will observe that there is a very thick cloud cover in these areas. That again, in a way, dissuades or discourages the formation of these lights. So the formation of auroras is actually dependent upon many variables. Only when all these variables align together are we able to see a lighted sky. Now, another small question that can come into your mind is that do all the solar phenomena end up producing only light? If that is so, why are we so afraid of these solar phenomena time and time again? Well, not all the solar phenomena end up as innate as just lighting up our Earth's atmosphere. Many of the times, they cause significant and very, very strong damage on the Earth's surface. These are what are referred to as solar storms. Now, when we come across this term solar storms, this is when the Earth's magnetic field aligns itself with the solar magnetic field in such a way that transfer of electrons happen in a very quick manner. Just to provide you a kind of imagination, suppose this is the rough representation of the Earth, and let us suppose here we have the magnetic field of the Earth on one side, and let us assume here is where you have the sun and the magnetic field lines of the sun as well. Now, sometimes these two field lines, they will interact with each other. And due to that, huge amount of electrons and plasma, they get transferred from the sun to the Earth's outer part of atmosphere close to the polar regions at a very short span of time. Now, what that does is, it significantly impacts the Earth and our atmosphere. So, when you look at the various impacts, one of the prime and very apparent impact is that here in this case, you will have huge amount of electrons which will then try to sink over these polar regions. Now, when you have such huge amount of electrons trying to sink over the higher portions or the upper reaches of the atmosphere, that will automatically end up creating its own kind of heat. And that many of the times leads to atmospheric bulging as well. But more importantly, day-to-day life is impacted in a significant manner by all the communication measures that we have, those being impacted. Now, I hope we are aware that right from the upper part of mesosphere, in the very portion or in the very structure of atmosphere itself, right from the upper portion of mesosphere up till around 400 kilometers, we have the presence of ionosphere. Now, this ionosphere is very helpful in order to aid radio communications. Now, ionosphere is nothing but again presence of gases in the form of charged particles or ions. That is why we call it as an ionosphere. Now, in this portion of atmosphere, whenever you have bombardment of electrons, when we see in the case of solar storms, ionosphere is impacted. And the properties of the gases, that is impacted as well. And that is when all the radio communications on the Earth, that is disturbed. Now, many of the times we see that long haul flights or long range planes which travel across various continents, they end up traveling through the polar region in order to save time, because that covers a kind of a displacement. Now, when these airplanes are traveling over the polar regions, they do not depend upon satellite communication anymore. Rather, they are dependent upon high frequency radio communication. So when you have bombardment of electrons and ionosphere getting disturbed, radio communications being impacted, travel across various continents is disturbed as well. But not only that, even certain satellites which are very innately orbiting the Earth's surface, even those satellites, their instruments, along with the various equipments, they also get damaged, and sometimes they get permanently destroyed. But these electrons and bombardment of the electrons on the portion of the Earth's surface or on the upper part of the Earth's atmosphere also leads to a phenomena whereby we end up observing electric current to be flowing on the Earth's surface. This leads to a very quick or a fast corrosion of all the pipelines that we have. All the kind of permanent infrastructures that we have, they get destroyed. Our GPS readings that we depend so reliably upon, those GPS readings, they get distorted. They no longer point to the perfect north or the perfect south. So overall, we can basically summarize that these solar storms shall have a significant bit of impact in any portion that they hit upon. And that is why it has been experienced that when you have occurrence of such strong solar storms, various different electric grid lines, even communication networks, as was experienced in the case of China in 2011, all of them, they are brought to a complete halt suddenly. So that is how solar matter interacts with the Earth, not only producing very beautiful lighted patterns, but also producing a certain kind of damage if these magnetic field lines align with each other. So basically, why is it that we observed the rotatory motion in these electrons, and why is it that we observed a kind of anti-clockwise circulation of these lights? That is because these magnetic field lines, when they were acting upon the northern poles at that point of time, they also had an east to west direction. So think about it. At one portion, the electrons, they want to sink down. And they also are experiencing a force which is taking them sideways. The result, all of them clustering in the form of a circular motion. That is why we ended up experiencing space hurricane. Now this is something, or this is an event which actually occurred in 2014 itself. But then at that point of time, it was not observed. All the data were recorded by the satellites. It is only upon further examination of these satellite data that scientists have been able to reconstruct what a space hurricane would have looked like. And now, once the scientists are aware of what a space hurricane looks like, what is the behavior of the electrons in that region, chances are that we will be experiencing, or we will be finding and discovering much more of these space hurricanes. After all, we have the presence of hurricanes and tornadoes which are already present across different planets and also across different moons of Jupiter. So this will further deepen our understanding of our own solar system and the properties of the sun. Now, to summarize it all, what is it that we have studied today. We have looked at what is it that we call as a space hurricane. Why is it that we name it as a space hurricane? Where is it observed? It is generally observed along the polar region. Why is it that it is observed in the polar regions itself? Because it is in the polar regions, the northern and the southern poles, where maximum amount of magnetic field lines shall be present. Now, why is it that Earth has magnetic field lines? That is because the outer and the inner core, which is composed of iron and nickel, that subtends a kind of magnetic property to the Earth in itself. And that is why, as the Earth keeps on rotating around its axis, the outer core, which is in liquid state, also ends up rotating, thereby generating a magnetic field. And this magnetic field interacts with very high energy particles and charged particles for that matter, which is emitted from the sun in the form of solar flares, solar winds, or coronal mass ejection. So that is why it ends up being observed in our atmosphere as northern and the southern lights, which are some of the most picturesque and beautiful atmospheric phenomena that you will come across happening on the Earth's surface. Now, this particular portion is very, very important for the examination, be it in prelims, be it in mains, or those of you who are appearing for the interview process. You can also expect this to be asked because this has been in relevance and in discussion in the recent times. So that is all that you have to know in this topic, and that is all that concerns us as far as the basic concepts when we deal with space hurricanes. Thank you for being with us. Like, share, and subscribe if you like this particular video. Thank you.